Hello and welcome to another algebra session. In this video, I'll be talking about algebraic expressions. And what's an algebraic expression? An algebraic expression refers to the collection of real numbers, variables, grouping symbols, such as parentheses, brackets, and so on, and algebraic signs, plus, minus, multiplication, division. For example, if you have 2x plus parentheses y minus y, 1 parentheses plus 4, or you have 3xy plus 2x squared plus 5. These are all algebraic expressions. Okay. Why? Because you have variables, you have grouping symbols, separated by plus or minus signs, or multiplication or division signs. Now, note, what we have here are just expressions. These are expressions, right? They are not equations because there's no equal sign. We don't have equal sign. So they are just expressions, right? Once you have an equal sign, it becomes an equation, right? So let's define some few terms here. What is the term? A term refers to a number or the product of a number and one or more variables raised to a power. So terms are separated by plus or minus signs. Now let's look at an example. So this is a term. 2xy, that's a term. 3x squared, that's a term. 4 is a term, right? Because this is made up of 2 times x times y. And this is 3 times x squared. And this is just a number that's called constants. And they are separated by minus and plus symbols. So this is an algebraic expression, right? So these are terms, the terms. Now let's look at this example here. What are the terms here? This would be a term. 2x plus 5 over 3 is the term. We're dividing two items here. 3x is product of a variable and a number, so that's a term. This is also a term, real number. So they are separated by minus and plus signs over here. Okay, so those are terms. So you should be able to identify terms in problems, because soon we'll be combining like terms to make expressions simple. Now, what's a variable? When we say a variable here, we're talking about the alphabet or the letters used in the terms to represent any number. For example, in the expression 2x plus 2y, the variables would be the x and the y. So this x here and a y, these are the variables, right? X and y are the variables. So the alphabet used to represent the numbers. Then we also have to know what we call the numerical coefficients. The numerical coefficient, this is the constant factor of a term. Constant factor of a term. So that is the number associated with a variable is the numerical coefficient. Let's take an example. If I take 3xy, right? Now the coefficient here is a number 3. So the number 3 will be the coefficient, the number associated with the variables, that's the coefficients. If I take an example, let's take negative 4xy. What will be the numerical coefficient? The numerical coefficient will be the number negative 4. Negative 4, because that's the number associated with the variables. So negative 4 is the numerical coefficient. Okay, so number in front of the variables. And what's a constant? When we say a constant term. So that's a term without an associated variable. For example, you have 2x plus 5. The number without a variable, which is the number 5, this is the constant term. So the constant is 5. All right. Then we want to talk about what we refer to as like terms. Like terms. Now, like terms, when we talk about like terms, now like terms, we're talking about terms that have the same variables with the same exponents. Two things: same variables with the same exponent. They're raised to the same exponents. All right. Now, let's look at an example. If I take 3xy, the variables that you have x, y, right? The same xy here. Yes, same variables raised to the same exponents, okay? So because they're the same, 3xy and negative 2xy, these are like terms. They look alike, okay? It's like they're from the same family. You can think of it that way. Or we can say they have the same last names, okay? So look at example B. Here we have 2x squared y and 5x squared y. You have x squared y here, x squared y. Same variables, same exponents. Right? Because they look alike, 2x squared y and 5x squared y are like terms. Okay, so these are like terms. Okay, so it should be identified like terms when we talk about combining like terms to make algebraic expressions very simple. Okay. So now let's look at how we can simplify algebraic expressions. How do you simplify algebraic expressions? Okay. Now, to simplify algebraic expressions, I want you to follow these steps. 1, you should be able to identify and remove any restriction on any term. What do I mean by this? That is, remove brackets, parentheses, braces, and so on by applying a distributive property. So you distribute the number in front of parentheses to get rid of the grouping symbols, all right? And always remember to start with the innermost group. You want to follow the order of operation. So you start with the innermost group. We'll see examples very soon to make this clearer. Then the second step is to group like terms. Now you're going to group when you finish terms that look alike. Group them, then simplify by adding or subtracting the numerical coefficients. You know, and then you keep the common literal factors or terms that the literal factors that they have. Okay. So let's look at an example. Assuming that you have 2 oranges, right? And you're adding 3 oranges. How many oranges would I have? I'm going to end up with 3 oranges, right? So 2 plus 3 oranges, which gives us 5 oranges. So look at what is happening here. So if you replace the oranges with a variable x, then you have 2x plus 3 is equal to 2 plus 3x, which is equal to 5x. Okay. So what do we see here? So you see that you are adding the numerical coefficients, Okay, that's what you're doing here. Okay, so 2 plus 3 give the common variables that they have. You don't change that. Okay. Same with subtraction. 5 oranges minus 2 oranges, you have what? 5 minus 2 oranges. So here that's 3 oranges, right? So if we replace the oranges with x, then we have 5x minus 2x is equal to 5 minus 2x, so which is 3x. So we keep the common variables that we have, all right? So let's do one quickly, combine like terms here and simplify. So let's say if I have 7x plus 3x, what would that be? Okay, so this will be 7 plus 3. So that will give us 7 plus 3, and then that will be 10x. x, okay, because you add the numerical coefficients. What else? 7x minus 3x. This time you're subtracting. Now this look alike, x and x, they are alike, so they're like terms. So once you have like terms, you can simplify. So 7 minus 3, and then that gives us 4. Keep the common variables that you have, which is this x. Okay, so it's like 7 oranges minus 3 oranges is equal to 4 oranges. Okay, something like that. All right, so let's look at one example, how to simplify algebraic expression. So let's look at the example right here, example 1 here. Okay, so what do we do? You have 7x minus 5, 2x, sorry, plus 7x minus 5 minus 9. Okay, so you're going to put the like terms together. We have 7, 2, x and 7 is alike, so we can combine them, right? And then 5, negative 5 and negative 9, they are alike, so we can put them together like this. Okay, so 7x plus 2x, what would that give us? 7x plus 2x, you have 9x right here. All right, that's where the 9x comes from, 2 plus 7. And then you have negative 5 minus 9, which is negative 14. So you have 9x minus 14 as your answer. Okay, combine like terms. Now let's look at another example, example 2. This time you have 2x. I'm going to rewrite this out here. You have 2x minus 5 minus 3 times 4 minus 3x minus 8. Okay. Now this time we have restriction over here. What's the restriction? The restriction is the parentheses, the parentheses. So we have the parentheses, you want to get rid of the parentheses. And that's why you have to apply the distributive property. What do you mean by distributive property? It means that if you have a number in front of the parentheses, that this number is multiplying everything within the parentheses. This number affects each of the numbers within the parentheses. To distribute or multiply each term within the parentheses by that number. So you're going to have 2 times x, and then multiply 2 by this number 5 here, or negative 5. Okay, so if you do that, you have 2x minus 10, right? So that's what we have here, step by step, 2 times x, and then 2 times the 5 here, right? So that's 10. So the parenthesis is gone. Now, when we get to this part here, you have negative 3 times 4. So that negative 12. Negative times positive is negative. And then negative times negative will be positive, right? So negative 3 times negative become positive. So plus 9x. Always be careful. You have a negative sign from parentheses. It affects or it changes all the signs within that parentheses. Okay. And then minus 8. Then we look out for the like terms. What are the like terms here? Now I have 2x here. That looks like the positive 9x plus 9x. So we're going to put these like terms together. That's what we call the grouping, the like terms. So we have 2x, write them down, plus the 9x. Then we have negative 10. That is a constant, another negative 12 constant, and negative 8 constant. So we put them together. So negative 10 minus 12, minus 12 minus 8. Okay. So 2x plus 9x, we put this like terms together, we have 11x. Negative 10 minus 12 minus 8, that'll give us negative 30. Okay. Combining like terms and simplifying. Now let's look at how to evaluate algebraic expressions. How do you evaluate algebraic expressions? When given specific values for a variable in an expression, we can use these given values to find a value for the algebraic expression by the following process. First, you substitute the given values for the variable. And then secondly, you evaluate the expression following the order of operation. For example, you've been given 3x, you have 3x, let's rewrite this out. Three x squared minus times y minus 2xy squared. So minus 2xy squared plus 7. And we're given that x is equal to -1 and y is -2, right? Okay. So it means that wherever you have x, you're going to replace with -1, and where you have y, you're going to replace with -2. Always rewrite this with parentheses, in place of the variables so that I don't make any mistake. So I'm going to write 3 and then parentheses to represent the x, and this is squared, parentheses for the y, minus 2 times parentheses for the x, and parentheses to put in the y, and this is squared, plus 7. So if you write this way, you never go wrong. And then you can put in given numbers. So x is given as -1. So we're going to put in -1. Let's put in -1 here. And then y is -2. So put -2 there. This is x, which is 1, -1 here. And this is -2. Now we're going to simplify using the order of operation. The order of operation. So we have to start with the exponents, because that's on a higher level. So we're going to evaluate the exponents first before we multiply. So let's evaluate the exponents. So here I'm going to write 3 times -1 squared. -1 times -1, that's all positive, right? So you get +1 and times -2. So I'm evaluating the exponents. Then 2 times -1, I'm going to evaluate -2 times -2 becomes +4. +4, and then +7. Okay, so evaluate the exponents. Now I'm going to multiply out. So we're going to multiply out this, then multiply out what we have here. So 3 times 1 is 3 times -2. So that gives -6. Then we have negative, I can type the negative sign to the 2. So it's -2 times -1, which becomes +2. +2 times 4. So that'll be +8. And then plus the 7. Since we are adding, we can just go left to right. So we have -6 plus 8, which will be +2. +2 plus 9. And then that'll give us what? +7, sorry. And that'll give us +9. So when you evaluate this expression with the given numbers, you get +9. Okay. So that's how you evaluate expressions. You place the variables with the given numbers and then simplify using order of operation. Now, another way in which you could be asked to evaluate expression, it's what we have here, where I have extra question. It says, that is here. Another way of defining a function or an expression in terms of x is to use the naming system, where we use f of x or g of x and so on. Okay, so see f of x, we read this as f of x or g of x, right? So the function in terms of, defined in terms of x, I mean, very easy to follow this. So could we have a function where they write something like this? they give you, you'll be given if f of x is equal to 3x squared minus 2x plus 7, you know, like the problem we just did. No, let's say similar to the problem we just done. Not the same, but similar. So f of x is equal to 3x squared minus 2x plus 7. And we ask to find f of -1, f of 2, and f of -2, and so on. So what does this mean? So this x is the input, right? Is the input. That variable is the input. It means if a function you input x, whatever, then this is the outcome, the input and outcome. That's what function here means. So we're looking at f of x equal to something. Let's call it, let's call it uppercase A here, all right? F of x. So the f is the rule for the function. Okay, so this is the input. Whatever I say is the input. And what you put into the given rule, you get an outcome. So the outcome is the output. Okay, so it's an input and output. Okay. So what we have here means that if I take the first one, find f of -1, it means that this -1 here is your input. You're putting in -1. So in place of x, you put -1. So let's try that one. So I go to a function. That's what I have done here. You take the f of x, so say f of -1 is equal to, what's the function saying? It says 3 times whatever the input is, that is squared. You're squaring the x, so x squared, right? So this is here, squaring. So I use parentheses and squared. Okay, minus, you have, what's the next one? Minus 2 times the x, or 2 times the input. So let's rewrite that out. So what I have is 2 times whatever the input is, and then plus 7. Okay, and what's the input? The input is a -1, so it's -1 for the x, -1. Okay, replacing the x with the -1, and then you evaluate. Okay, so now focus is just on the right side of the equation here. So deal with exponents. 3 -1 squared is 1, minus 2 times -1 plus 7. So I've dealt with the exponents. Simplify. 3 times 1 is 3, -2 times -1, the positive 2 plus 7. If we put all this together, you get 12. So your f of -1 is equal to 12, right? So that's what I did over here. Okay. So I hope this is clear. Okay. All right, let's try one more example here, and then you can try that one yourself. F of 2, right? F of 2. So the function f of 2. So that's the function f. So I go f of 2 is equal to, say, 3 times, say, square the input, which is this, minus 2 times the input, which is a 2x. So x is 2, and then plus the 7. So you have 3 times 4 minus 2 times 2 plus 7. Okay, I dealt with exponents. Now I'm going to multiply. So 12 minus 4 plus 7. And what would that be? 12 minus 4 is 8. 8 plus 7. So that would be 15. Okay, so your f of 2 is equal to 15. Okay, great. So that is how you can also get a question on evaluating algebraic expressions, right? I want to touch on another area known as polynomials. Okay. So what are polynomials? A polynomial is an algebraic expression that consists of one or more terms in which all the variables are raised to a non-negative exponent, negative integer powers, all right? Non-negative, so very important. It's an algebraic expression, we know what expression is, but if now this one consists of one or more terms in which all the variables are raised to non-negative powers, it means I can have a negative exponent, negative integer powers, integers. In my other video, I spoke about integers. So integers are whole numbers and they are opposites, right? But this time we're talking about non-negative. So I can have negative exponents. Like 1, 2, 3, 4, 5, and so on. You cannot have a fraction because fractions are not integers, right? So example, you have 2x squared plus 3x plus 2. This is an algebraic expression because I don't see any negative integer here. So that's an algebraic expression. Now this is an algebraic expression because there's no negative integer and so on. Okay, and there's no, there's no fractions as well. So remember, integers are whole numbers and their opposites, right? Those are integers. But for polynomials, you only want the positive integers. Right. Now, polynomials, they have special names for the first three. Now, if you have one term, just like 2x, then you call a monomial, only one term, monomial. Mono means one. You have two terms, so we have x squared, s cubed, plus 6. So it is two terms. And we define terms already, so you know what terms are now. So if I add two terms, it's called a binomial. Bi means two, right? So binomial. You have three terms, trinomial. So you have 1, 2, and 3. Three terms put together. Okay. So they have, these are the special names for the first three. Now, anything more than 3, we just refer to them as polynomials, right? Now let's talk about what we call the degree of a polynomial. What's the degree of a polynomial? Now the degree of a polynomial in one term, one variable. Let's take one variable first. In one variable is the exponent of that variable, okay? So if I have a monomial, let's say 2x, monomial 2x, what is the exponent of you have only one variable here, what will be the exponent of that variable? It's 1, invisible 1. So this is a first degree or degree 1, okay, which we call the first degree monomial or polynomial. What about this one? You have only one variable in this. Now the exponent here is 2. So this is a second degree or degree 2. Okay, so this is a second degree monomial or polynomial. Now this one variable exponent is 4. So this is a fourth degree polynomial or degree of 4. Okay. So that's how you deal with a monomial, the degree of monomial. Okay. Yeah. If you have just one variable. Now, what about the degree of a constant term? A constant term. So a number like 2, 3, 4, and so on. So degree of a constant term is always 0. So that constant term, degree of 0. Okay. And what's the reason? This is a reason. Okay. If you want to understand why, let's go to the first one. The reason you have 2x, 2 is the same as writing x raised to the power 0. Any number raised to the power 0 is always equal to 1. Okay, it is always equal to 1. Whatever is here it's 1. X to the power 0 is always equal to 1. Any number. So if this is 1, then you have 2 times 1, it's always equal to 2. So 2x to the power 0 is 2 times 1, and that is 2, right? That's just a constant. So that is missing. That means that's why the exponent is 0. So that's why the degree is 0, because the exponent is like x to the power 0. Right. Now, what are the degree of a zero? A degree of the number 0. The number 0 has no degree. If 0 has no degree, okay, no degree. Now, what about the degree of a term in more than one variable? Now we have more than one variable. If you have more than one variable, this is what you do. So the degree of a term in more than one variable is the same as the sum of the exponents of its variables. So this time you're going to add the sum or find the sum of the exponents of its variables within the term. All right. For example, if you have 3xy, okay. So 3xy, what do you have here? Look at the exponent. The exponent of x is 1. So you have 1 as the exponent here. Now what's the exponent of y? The exponent of y is also 1, invisible 1, okay, which we don't write, but there's 1 there. So you have the sum here is 1 plus 2, and then so that gives us 2, right? 1 plus 2, so which is 2. So in this case, because the sum of the variables here is 2, the degree of this monomial more than one variable is 2. Okay, 1 plus 2. So it's a second degree polynomial. Okay. What a degree of 3 to the power 4 y. 3 to the power 4 y. So you have 3 x, 4, and y. We have two variables here. So because you have two variables here, then you add up the exponents, right? So we have 1, invisible 1 for y. So that means that we have 4 plus 1, and that gives us 5. Okay, so the degree of this monomial here is going to be 5. It's a 5th degree polynomial, 5th of 5. Degree of 5. Okay. So that's what we have here. Okay. Now with that knowledge, we should be able to determine the degree of an entire polynomial that's given to us. Okay, let's try that here. So the degree of a polynomial, the degree of a polynomial, the polynomial is the same as the degree, the same as the highest degree in one of its terms, the highest degree in one of the terms. So let's say we've been given 2x squared plus 3x plus 2. Let's determine the degree. So to determine the degree, we'll take each term. So let's begin. We're going to take each term. So if I take the first term, 2x squared, what is the degree? The degree of 2x squared. Okay, only one variable here. So the exponent is the degree. So that is 2. So that's this here. 2. Then what about the next term? 3x, one variable, exponent is 1. So the degree for that one is 1. So we have here, we have 2 there. Degree for this one is 1. And what about a constant term? 2 is a constant term. Then we say the degree of a constant is always 0. So this is 0, right? So we found the degree of each term. Now the degree for the whole polynomial is going to be the highest. The highest one determines the degree. So since 2 is the highest, 2 is the highest degree of all these terms, the whole polynomial is a second degree polynomials, second degree. So degree of 2, because 2 is the highest amongst all the terms, all the degrees. Yeah, right. So it's the second degree, right? Let's try another one. The next example, this example here. Okay, so for the first term, what's the degree? The first term here, the degree for this is going to be 2. That's the exponent here. Degree here, this term here, the degree is going to be 4. Degree for this here we have 2 variables here, right? So since we have 2 variables, we have to add the exponents of this, and then if add the exponents of that, 4 and 1. So we have, this is a 5th degree for this term. So what's the degree of the whole polynomial? The degree of the whole polynomial will be the highest among the degrees. So the highest among the degrees is 5. So 5 is the highest for all the degrees. So this whole polynomial is a 5th degree polynomial. 5th degree polynomial. So that's the highest degree. Okay, right. Okay, let's try one more. This example. So degree of the first term, 6x to the power 5 and y to the power 2. We have 2 variables in this term. So add up the exponents and that becomes a degree. So this is a 7th degree here. X and y in the same term, 1, 1, exponent is 1 and 1. So 1 and 1, so this is a 2nd degree polynomial, right? So since 7 is the highest of the degrees, the whole polynomial is a 7th degree polynomial of degree 7. Okay, right. So that's how you determine the degree of the whole polynomial. Okay. Now, finally, we want to talk about what we call the leading coefficient. The leading coefficient. What is the leading coefficient? Now, this is the coefficient of the term that determines the degree of the polynomial, the coefficient of the term that determines the degree of the polynomial. Okay, so let's look at this example. So what would be the leading term of 2x squared plus 3x4, 7x to the power 4y? Okay, so we're going to determine the degree. So let's try that here. So the degree here, the first one, 2x squared, the degree for this is what? Is 2, right? Degree for this one is 4. Degree for 7x to the power 4y, a degree here 4 plus 1, so this is a 5th degree. Okay, so these are degrees. For each term. Now, in the standard form, what we call the standard form, in the standard form, you always arrange the terms in descending exponents, right? So in other words, start the highest degree first. So since 5 is the highest degree here, in the standard form, we're going to write this as 7x to the power 4y. So this will come first. Okay. This will come first, followed by degree 4, which is this one. So follow that by the minus 3x4, and then the lowest degree, which is 2. So this term, which is 2x squared, will be written next. So plus 2x squared. So this will be in the standard form, okay? Standard form, that is descending degree. Okay. So the leading coefficient will be a coefficient of the leading term. So when we come here, the leading term is the first, the one with the highest degree, right? That leads, the term that leads in the standard form. So this is this. So this will be the leading term. Leading term, 7x 4y. Okay. And then the leading coefficient will be the coefficient of that leading term. So what will be the leading coefficient here? The leading coefficient here will be the number 7. So 7 will be the leading coefficient. Okay. So 7, that it's 7 because the term 7x4y determine the degree of the polynomial. All right. So I hope this helps you understand what polynomials are, algebraic expressions, and how to find the degree of polynomials. Hope to see you in my next video or more lessons. Bye-bye.